Welcome back to Module 9.7. In this lecture video, I'm going to continue to solve our linear inequalities. So same steps as with the equal sign, okay, except the very last step when the coefficient is negative. After we divide, make sure you switch the inequality to the opposite one. So let's take a look at this first example. On the left side of the inequality, I got two terms. And then on the right side, I got one term. All of the three terms, none of them has parentheses, so there's no distribution needed. Cannot combine these two terms on the left, so let's move them. So this is the negative 3z is the only variable term I got. So what I'm going to do is move it to the right side. At the same time, I'm going to move my negative 16 to the left side, okay? So moving terms back and forth across the inequality does not change the inequality. So that stays the same. Negative 3z come over, become positive. Negative 1 still negative 1 on the left. Negative 16 come over, becomes positive. All right, so combined like term, this is going to be 3z less than equal to 15. Divide both sides by a positive 3, though. Not a negative, but positive. My z will be less than equal to positive 5. All right, so if I read from the variable, that means I'm looking for numbers that are less than or equal to 5. So lesser than equal to 5. 5 is about right here. Lesser than 5 is everything to the left. All right. So since I'm using equal to, that means I will use a closed interval or using a bracket. Okay, that's a 5. All right, reading my graph from left to the right, my interval notation got to be from negative infinity all the way to 5 for answer. And 5 is using a bracket. Okay, that's how I will write the interval notation. This is how I will graph it. So the homework is doing this a little bit backwards. It's kind of asking you to look at the inequality and write out the interval notation. So in your mind, you can kind of think about it, or you can kind of sketch it before you go to the step number 2. 5, everything less, that will be to the left, to negative infinity, using a bracket. You can kind of sketch it if that helps you to write the interval notation, okay? All right, let's take a look at another one. So let's see. None of the 4 term has parentheses, so no distribution. I see there's no like term to combine on each side, so let's move them. 3x right here, negative x on the right. The 3 is bigger than negative x, so I'm going to move all the x's on the left. That means the negative 5 need to go to the right. So inequality stays the same, okay? 3x is 3x. When negative x come over, it becomes positive. On the right side, positive 3 is still the same. Negative 5 come over, become positive. So combined like term, there's 4x greater than 8. So divide both sides by 4. My x is going to be greater than 2. So x greater than 2 means I'm looking for all the numbers that are greater than 2. That will be to the right side of 2. Since I don't have an equal to, then I will use parenthesis, open interval. So by looking at this graph, I can see my interval notation got to be from 2, using a parenthesis, comma, all the way to the right to infinity. All right, let's check out a different one. So this one contains fraction. So you can choose to work with a fraction or clear the fraction, okay? It's totally up to the students. Here I'm just gonna clear the fraction. My LCD is gonna be 3, so all 4 terms times by the LCD 3. So again, you can work with a fraction or clear the fraction, okay? Times by 3 means 3 over 1. That put all the LCD on the numerator, reduce with the denominator. So that will be 1 and 1. 1 times negative 2z, negative 2z. All right, plus 3 times 9 is 27, less than. All right, top 3, bottom 3 cancels out into 1 and 1. So that will be 2z times 1, which is 2z. Positive 5 times 3 is positive 15. All right, so the 2z on the right is bigger than negative 2z on the left. So I'm going to move all the z to the right side. So let's move this negative 2z over. So inequality stays the same, okay? This 2z is already there. When the negative 2z come over, it becomes positive. On the left side, 27 still 27. When positive 15 come over, it becomes negative 15. So here, when I combine like term, that will be 4z equal to 12. So divide both sides by a positive 4. My answer, z, right? Z is greater than 3. So I'm looking for all the numbers that are bigger than 3. That means it's going to be to the right side of 3. So if that's 3 right here, looking for all the numbers bigger than 3, that will be to the right. My inequality does not have equal to, so I use open parentheses. So the interval notation got to be from 3, keep on going to the right to infinity. All right, that would be the answer for both steps. All right, this example, now I'm having parentheses where I got to do a distribution. So 1 term on the left, 2 term on the right. First term, a quick distribution. That gave me 4z, positive 12, greater than or equal to 2z, plus 18. All right, no like term to combine on each side, so let's move them. The 2z need to go to the left because 4z is bigger. At the same time, I'm moving my positive 12 over. So with the inequality still the same in the middle, 4z is 4z. Positive 2z come to the left, become negative. 18 still 18. Positive 12 come over, become negative. So when I combine here, that's 2z greater than or equal to 6. Divide both sides by positive 2. My answer got to be z, still greater than or equal to 3. Okay, so as long as I'm dividing by a positive coefficient, the inequality stays the same. So looking for all the numbers that are bigger than or equal to 3. So that will be from the 3 to the right. Since my inequality contains an equal to, I will use a bracket. Brackets, everything from 3 to the right. So by looking at my graph, the interval notation from left to right got to be from 3 using bracket, comma, all the way to infinity to the very right. Alrighty. Oh, here's another fraction one. Let's take a look. An LCD here is going to be 12, right? So I got 3 terms. This 1 term on the left, plus sign here, tell me there's 2 terms on the right. So all 3 terms will times by 12. Times by 12 means 12 over 1. Because my first term, top 12, bottom 4 reduced into 1 and 3. So this 3 will now multiply both of these terms on the top. So I'm going to write both of these terms on the top in the parenthesis. Because it's 2 terms representing 1 numerator up here. So that's why I got to put them in the parenthesis. Greater than. All right, my second term times by the LCD 12. That will be 1 and 4. So the 4 will now multiply both of these terms on the top. 2 terms representing 1 numerator. That'll be 4 times, that'll be 4 times parenthesis, x plus 1. All right, my last term, positive 1 times 12, positive 12. Okay. So my first 2 terms has parentheses, so let's do our distributive property. So that will give me 6x, positive 9, greater than 4x, 4 times positive 1, positive 4, and still got my positive 12. Combine like terms on each side. These 2 terms can be combined. So I should get 6x positive 9 greater than 4x plus 16. So since the 6x is bigger than 4x, let's move my 4x over, become negative. So that'll be 6x minus 4x, which is giving me 2x. All right, positive 9 move over to the other side, become negative. 16 minus 9, right? 16 minus 9. Let's see what it's going to say in my calculator. Give me a second. Let me bring my calculator over. That'll be 7. All right. So divide both sides by 2. My x is greater than 7 over 2. 7 over 2 is about what? It's actually 3.5, right? So you can move your cursor, okay, to 3.5, which is between 3 and 4. So that'll be somewhere about right here. If I say 3 is here, 3.4 will be about right here. Looking for numbers that are bigger than 7 over 2. So that will be using parentheses, everything to the right. All right, so my interval notation got to be from parentheses, starting from 7 over 2, comma, all the way to the right to infinity. All right, so in this lecture video, we talk quickly about how to solve linear inequality using interval notations to describing our solution. All right, that will conclude this lecture video. Thank you for watching.